Now, this question looks a lot more difficult than it actually is. You're given a circle with radius r. We're told the centre of the circle is the point 0, 0, and we're told that the angle that the radius of the circle makes with OP makes with the positive x-axis is alpha. And the first part says write down the coordinates of P in terms of alpha for the case when r equals 1 and r equals 5. So it says write down, so it can't involve a lot of work if it says write down. Generally, it only needs 1 or 2 steps. Now, for a unit circle, a circle of radius 1, the x-coordinate is always cos alpha and the y-coordinate is always sine alpha. If the circle has got a radius of 5, then obviously its radius is 5 times as big, and the x-coordinate is going to be 5 cos alpha and 5 sine alpha. So you could just work it out quite quickly, as I've just said, from memory. But if you don't remember it, it's not that difficult to work out, as long as you remember the general where these results come from. So if we're looking at the radius, the x-coordinate of P is this horizontal line here. The y-coordinate is this vertical line here, and we're making a right-angled triangle there. So the y-coordinate of P, which is this bit, I can work out using trigonometry in terms of r and alpha. I think y is the opposite angle alpha, and r is the hypotenuse. So opposite and hypotenuse gives us sine. So the y-coordinate of P divided by r equals sine of angle alpha. Sine of angle alpha is opposite over hypotenuse. So that if we multiply both sides by r, we get y equals r sine alpha. Similarly, if we want the x-coordinate of P, well, the x-coordinate of P is this distance here, and relative to this angle alpha, x is an adjacent side within this triangle, and r is the hypotenuse. So we're using adjacent over hypotenuse. So adjacent over hypotenuse, x divided by r, is equal to the cosine of angle alpha, or cos alpha. And if we multiply both sides by r here, we get x equals r cos alpha. So in general, if we've got a circle of radius r, and we're looking at a point on that circle where the radius of that point makes an angle alpha with a positive x-axis, the x-coordinate is r cos alpha and the y-coordinate is r sine alpha. So when r is 1, x is 1 cos alpha, or just cos alpha, and y is 1 sine alpha, or just sine alpha. So I think we're looking really, if we're using brackets, then the coordinates for P are cos alpha, comma, sine alpha, comma, sine alpha, close bracket here. And for r equals 5, x is 5 cos alpha, y equals 5 sine alpha. So if we're using it as writing this as an ordered pair, we're writing 5 cos alpha, 5 sine alpha, like that. Now, part B we can answer in a couple of ways. We're told that r is 5, so we know this length is 5. And we're told that PS coordinates 4.24 and 2.65. So what we know is that this distance is 4.24 and this distance is 2.65. And we want to work out what size angle alpha is. Now, we're actually a little bit spoilt for choice because we could say that cos alpha equals 4.24 over 5, and then work it out, or sine alpha is 2.65 over 5, or even tan alpha is 2.65 over 4.24. So we can take our pick. If I'm going to use 4.24, then I've got 4.24 is the x-coordinate, so 5 cos alpha is 4.24, all right, or cos alpha is 4.24 over 5, and so cos alpha is 4.24 over 5. So if I use inverse cos, so cos minus 1, 4.24 over 5, comes to 32 degrees. So that's a sine of angle. That's the size of angle alpha.